maybe you don't need to know how to do Python, but you're going to need to know how to prompt these models to get exactly what you want. And that may actually be slower than just learning Python.
There's a reason why we learn math. There's a reason why we learn algebra. There's a reason why we learn the elements of physics or any of these things when we're kids. It's because those help us to learn base principles, to be able to essentially do anything else, to go on to be creative and to put these things together in unique and novel ways so we understand the world. And I think programming is one of those base principles.
If and when there is any sort of disinformation risks, people seeing the first video or the first post will likely not see the retraction or the story about something being fake.
Historic security systems might be failing now with the advancements in AI. What are the implications of those specifically relating to security?
That concept of using those LLMs to kind of go out and do their own research is definitely a dangerous thing, because they have kind of an infinite amount of time. It just depends on how many GPUs you have.
Hunter, welcome back to the Ken's Nearest Neighbors podcast. It's your second, possibly second appearance, yeah. And I obviously just moved to Austin. You're living here. I figured, why not do something in person? Chat a little bit. A lot has changed since the last time we talked, especially
for sure
in the data science and AI space. And I wanted to get some of your takes, especially as it relates to security, which is sort of your hybrid domain here.
Sure. Yeah, I think obviously always interesting and fun to talk with you. I get to see you maybe like 2-3 times a year, and now since you'll be in Austin, like hopefully quite a bit more. So
slightly more, even though you're moving away potentially right when I'm getting here, but not
only
too far.
Dallas, exactly. Yeah, not too far.
So I wanted to start with something interesting. Since people have already heard your story, if they go back to listen to the previous episode with you, I'll link that in the show notes, obviously. But the CEO of NVIDIA, he recently came out and said that he doesn't think kids should learn how to program anymore. I thought that was an interesting and bold statement. Obviously, it was framed in the idea that, hey, we've eliminated the need for programming with the advancements in AI technology. That was a stopgap or an intermediary to be able to get an end result. But how do you feel about what he's saying? Is that something that you generally agree with? Is that something you disagree with?
I think it's a funny, like the concept, I think, of these LLM models has had people are kind of, I think, coming up with very hot takes that if you just backtrack a little bit and understand maybe how programming has evolved, you could say the jump from people coding in machine code with punch codes to assembly, all of a sudden everyone, you don't need to learn machine code. Correct. But assembly is still, programming language of sorts, right? Then you go from assembly to like C. And again, now hopefully you don't have to learn assembly, but C is still a programming language. And, as you get higher and higher levels, maybe the LLM is something that's going to be eventually writing you Python code, but you still have to understand how to work the LLM. The LLMs are, especially with the English language, you could ask the same question and expect 4 or 5 different kind of variations on the same question, because English language in general is like imprecise. You could have a concept where you're trying to program something to do something, and maybe it gets 100% of what your question was, but the implied or your thoughts on what you actually wanted were slightly different. And so understanding, maybe you don't need to know how to do Python, but you're going to need to know how to prompt these models to get exactly what you want. And that may actually be slower than just learning Python. So there's some, and I think as the models get better, there'll be easier ways to tweak them, but it's still going to be kind of a technical, some sort of formatted question and answer. It'll be very hard for a model to kind of tease out exactly what you want, exactly what the requirements are. And maybe if you're writing in some sort of requirements, YAML file or something, and it generates code, great. But you're still going to have someone that understands enough to write the YAML to ask it to do what you want, until you have, something that you say, build me Netflix copy, and it just knows all the components and systems. And And even then, maybe decisions Netflix is making is not really what you as a small Netflix competitor would actually do in the real world. So
I agree with you. I think that the LLMs are a natural progression to programming languages, right? Ideally, and I've said this in the past, ChatGPT is the next programming language we use. But if you look, for example, at my master's in computer science, I went in and I learned assembly, right? I learned a lower level language like C. I learned another language like Scala. I learned also Python and some of these more, I guess, technically easier to use languages.
Higher level.
That are high level. But I had to learn those other languages to be able to understand how to think about programming in general. I obviously learned Java as well, object-oriented. And I understand what the CEO is saying, but I also think that that's a little bit, it has to be for dramatic effect. Because if you're going to tell me that I shouldn't think like a programmer, to me, that is the most important thing that I learned throughout all of the degrees that I've studied. It was not any specific programming language. It wasn't any specific tool. It was the idea that, oh, there's a systematic approach to how all these things work. We can build these things in parallel. We can create objects, and you have specific requirements around each of those. You don't want them to serve more than one purpose. There's a great organization in programming that I believe is very effective in helping us to critical think more effectively. There's also benefits of learning documentation. There's benefits of learning collaboration in these systems. And to me, those elements are taught through learning how to program. And if you're trying to program an LLM or talk to an LLM to get a result without understanding how to think about programming, you're going to have disastrous results.
Yeah.
So to me, the idea of don't teach your kids how to program is a clickbaity thing to say, because he's talking about in the like most real terms, they technically wouldn't need it. But I'm a firm believer that you should have it. There's a reason why we learn math. There's a reason why we learn algebra. There's a reason why we learn the elements of physics or any of these things when we're kids. It's because those help us to learn base principles, to be able to essentially do anything else, to go on to be creative and to put these things together in unique and novel ways so we understand the world. And I think programming is one of those base principles. It is an extension of math. It is an extension of a way of thinking. And that framework to me is really, really valuable. You know, I'm not saying out of the womb kids have to learn how to program, but if you can learn how to think like a programmer, but you can also learn how to think like a writer and some of these other people, like disciplines or philosophies, I believe that is truly what carries you really far in life. And for him to say that, I think he's sort of shutting out a lot of really good learning that kids or parents might have. And to me, that's a little bit disappointing. It's a little bit getting too caught up in the AI boom.
Yeah, I think there's kind of two answers I have to kind of the thought that you brought up there. First one, his job is to sell more GPUs. It's to kind of build the hype cycle. His company is obviously
they're doing
well in terms of selling very expensive GPUs, high margin, all that sort of stuff. I think the second piece, what you're talking about there with the kind of, I'll call it basically just problem solving skills that you learn from coding. You definitely also learn similar problem solving skills in those kind of basic education. I did engineering for undergrad. So, you know, in my electrical engineering classes, I took a variety of different things, and maybe I don't use like wireless principles and kind of the Fourier transforms in most of the work that I do today. But a lot of understanding how to solve problems is you build a toolkit and then you try and map problem that you've seen and how it was solved onto whatever new situation. And I think it's very similar for programming, right? You as you build up things that you've done yourself, you get a little bit more of an intimate knowledge of like, this component could be used over here to solve this problem. You're probably not going to lift and shift the entire system, but like 10 different components may make a great system over here, and they weren't kind of done and set up all, you know, in a clean thing for you right there. And that kind of thinking of how to solve the problem or how to architect something is going to be something that if you don't do the like legwork of learning how to think or learning how to program in some of those ways, let's say learning how to program is like almost like a thinking exercise. Like a lot of times you can do a variety of different brain teasers in any problem domain, and those let you grow. Even in something like chess, you can do a bunch of chess puzzles and then you'll become better at chess. Programming, I think, is similar in terms of you can do quite a bit of like laying the groundwork, understanding different sides of things, and then basically those little pieces, your brain will kind of start to put together a better picture of how things fit together. And until LLMs are at the point where it can maybe understand what you're thinking, which would be like some sort of brain chip or something in there, I think you really would need quite a bit of that. And even with those, maybe what you're thinking about would be the result of doing a bunch of different exercises and trying to fine tune something to be exactly kind of what you imagined.
Yeah. Well, I mean, you talked about engineering. I think engineering, incredible discipline, physics, math, all of these different domains are great for helping you to learn those base principles that are important. I personally think programming is one of the best learning tools for those things, because in programming, there's immediate feedback. Mm-hmm. You're able to build things and see if they run or work, but it's also open-ended in the sense that you can build whatever you want. And that creativity, being able to think objectively and build big structures and systems that potentially have never been built before, or applying your imagination to those things, is really valuable. Mm-hmm. I think in the more, for example, math, physics, traditional disciplines, you're not necessarily leveraging your imagination in the same way. I think at the very far end of the spectrum, where you have researchers, people pushing the cutting edge, they have to use their imagination. They have to be able to think essentially outside of the box. Mm-hmm. But as a student learning those things, you're not thinking and delving into necessarily new territory. Whereas in programming, I really believe that you are. That's not to say one is better than the other, but I think if we're talking about learning and developing skills that are inherently useful in the workforce or in the world, or even if you're not a programmer in life, I find that those are unbelievably compelling, at least from my experience. And again, my experience is not universal. There's a lot of things I've missed out.
Yeah, I think kind of playing off that, the feedback loops in programming are much quicker. If you think of almost like learning as an agile experiment or something, you're failing quicker and learning faster. Even then, let's say you're inventing something and you're trying to 3D print something, you model it in your computer software, rotate it around, looks good, try and print it, some issue. That whole cycle is like a day or a couple hours, depending on how fast you print, how big the thing is. With computing, you write a couple lines, you get an error, fix the error real quick, maybe see the results and say, that doesn't look right, fix things. So your feedback loops are generally a lot faster, which probably leads to like quicker learning.
Yeah, I agree 100%. Well, speaking of quicker learning and acceleration, we're seeing a lot of advancements in AI models more recently. Mm-hmm. We have Soma that came out. I heard something about Mamba, which is one of the new training methodologies for a lot of these LLMs, which I thought was really interesting. I haven't necessarily dived too deep into it yet, but I think it's Cloudbike is a YouTube channel I really like about. I don't know how it keeps up with all this stuff so fast. It's very impressive. But
a lot of,
what do you think about these advancements that are coming down the pipeline? Obviously, we're looking a lot at LLMs. That was really hot, but now we have generative video that's looking very promising. What roles are those going to start playing in society?
I think there are quite a few different aspects you can take this in. You could say, first of all, with any one of these models, every time they're released or about to be released, people freak out about disinformation. This was GPT-2, was so dangerous that they couldn't release the models except to researchers for like a year. And now there's people that make open source versions of, better, far more powerful than something like GPT-2. Just release it, and we haven't had seemingly mass negative effects yet. Maybe it's just we're not noticing, and the flooding of social media with all these bot posts is maybe worse. I haven't seen anything that tells me that we have seen a lot of those negative effects. I think if you look at video, people can edit videos, people can and have transpose someone's face on another image or another video and pretended like that is another person, whether that's for, trying to defame them or trying to, do something malicious. I think those technologies already exist at a slower scale. You have to have maybe more of that experience in terms of the domain and being able to, Photoshop some of those things. I think any of these tools make those things easier, which is obviously, especially in video, going to be maybe, something that people care more. I think, yeah, you look at kind of if and when there is any sort of disinformation risks, people seeing the first video or the first post will likely not see the retraction or the story about something being fake. So if it's not immediately apparent to the user that this is generated in some sort of, satire is oftentimes what people hide behind for those. And if it's not generated and it's not apparent that it's generated in one of those, I think you can have quite a bit of kind of polarization in terms of people that see something and only get the first half and have a thought about a situation. Plenty of different wars out there in the world. If someone's making AI generated war footage that show war crimes in some way, shape, or form, and it later comes out that they're generated and not real, I think there's plenty of potential harm that could be out there, because basically the first video that everyone sees is usually the thing that blows up, and the retraction or the calls to say, hey, this is wrong or this is an issue, usually don't get as widely spread around.
This episode of Ken's Nearest Neighbors is brought to you by Z by HP, HP's high compute, workstation-grade line of products and solutions. Z is specifically made for high-performance data science solutions, and I personally use the ZBook Studio and the Z8 workstation. I really love that the Z workstations can come standard with Linux or WSL2, and they can be configured with the Data Science Software Stack Manager. With the Software Stack Manager, you can get right to the work of doing data science on day one without the overhead of having to completely reconfigure your new machine. Now back to our show.
I think
I have to do a retraction myself, is because I don't think I gave people enough credit in the long term. With the prevalence of different tools, of people being able to spam a ton, put all this stuff out there, I guess I kind of forgot that people acclimate to that and they just don't really trust anything. Mm-hmm. And it seems to me like we're just losing trust in a lot of stuff that we see on the internet in general. And maybe that's not a bad thing, especially as that coincides with more stuff that is not trustworthy on the internet. I think that it probably varies by generation. I think my parents are a lot more apt to believe something they see on the internet. But Gen Zs, people, I'm a millennial, I think you're also a millennial. Yeah. We're probably less prone to see that because we have an understanding. And maybe it's because maybe I'm in an insulated community where with a bunch of data scientists, and they're like, yeah, why would we trust anything? It could be generated, whatever it might be. But that to me is a little bit refreshing in the sense that I believe I'm starting to see humans adapt to this in a way that is a little bit better for the overall world. Is that if we're skeptical of all the information that we see, we start to make our own decisions a little bit more. Mm-hmm. And if we think about politics, if we think about any of the situations that are happening in the world, maybe it's better that we're skeptical or a little bit skeptical of everything. Yeah. On the other hand, you start to run into an issue of, hey, where is truth located in this equation? And that can be a lot harder to understand and solve and follow. I think that the world is moving a little bit more towards localized media again, rather than this globalization of media push. So you look at Substack, you look at some of these other platforms where people are following individuals because they trust that individual to give them realistic and useful news. It seems like how news used to be before Pulitzer and before some of these people. And for the record, Pulitzer, there's an award after him, but he was hugely in favor of biased media. He thought it was his job to tell the story that he believed in, not necessarily the objective truth about media, from what I understand, just from listening to his biography. But to me, there's benefits to that, where you get your news from more of a singular source. The drawback is if those sources are heavily biased, it's like a machine learning model, right? You can be you can have high bias with low variance, which is one person who you really trust, who's very consistent but is completely off the mark, or you can have maybe dramatic variance and dramatic bias in what the general population of news is looking like right now.
Yeah.
And so I think it's an interesting perspective to say, hey, maybe some of these changes are good, maybe some of these changes are bad. What does the landscape look like? How do I, as an individual, want to get my news or think about these problems? I think that's hopefully the most important thing we can do.
Yeah, I think with the concept of the news and these models, oftentimes people think about like the LLM, replacing the writer. I think there's an interesting other place that I've heard of people trying to kind of attack this problem is basically if you feed in a bunch of news articles about the same topic from a variety of different opinions, that you could basically have a model that's trained to pick out all that information and try and figure out what the objective truths are that like everyone from all corners agree on, which is a quite interesting application of one of these tools where maybe you don't want to read 20 different articles on the same issue, but you want to read like the core facts that everyone agrees on. That's a just distilling information problem of running through and basically just saying these 10 sources all agree on this one thing. This more than likely true. And maybe you put some sort of like 10 of 20 say this, 5 of 20 say this, 19 of 20 say that. And you just have a list of here's the facts on this thing. And then maybe on the other side of that, you take something and you have it write you a nice, beautiful article given those 20 facts. And you maybe have some thresholds and tuning on if a high enough percentage of the sources say, X, Y, or Z included in the article, otherwise included in the footnotes or something. And I think perfect use of LLM there as like a kind of filter to take both sides or 3 or 4 sides of an argument with everyone with their own biases, and get a better kind of more objective understanding of things. Again, that matters, how you're training it and how you're understanding. There's a lot of layers of how something like that would work or how it could fall apart. But an interesting application that I've heard, at least kind of in a hackathon, someone put something similar to this together, like a proof of concept, basically.
That's something I would use. That makes a ton of sense. I mean, I personally, I don't really talk about my political views, and I'm like, pretty moderate, right in the middle of things. And it's very frustrating for me to look at all the media sources, and it's either like a left-leaning media source or right-leaning media source. And it's sort of like, well, why can't I just have like all of that combined and I can sift out what both parties, or at least in the US, are looking at, and I can see what opinions slant either direction. And to me, that helps me to be hopefully more objective.
Yeah.
I mean, I have a lot of problems with objectivity and the lack of it in politics and in the media and a lot of these types of things. And of course, there's no true objectivity, even with a model, but at least to have some semblance of where different people stand and who is saying what is really interesting to give context to anything. I think context with these models is something that is really important in general. I mean, something that I've been thinking about is on LinkedIn, on Twitter, on all these places, I am writing all of my own posts again. I was trying to use ChatGPT a little bit, but then I realized that unless I prompted it unbelievably well, which would take me longer than to write the stories, the content that was produced from ChatGPT is a caricature of the content that is released in the world. So on LinkedIn, a LinkedIn post on ChatGPT, you say, hey, make me a LinkedIn post. It has all these weird emojis. It has what the quintessential LinkedIn post is. Mm-hmm. And the question is that good content? Is that informative? Is that even useful? It's not producing what a quintessential good LinkedIn post is. It's producing what a quintessential LinkedIn post is. Mm-hmm. And I think that hurts us quite a bit because we're all working off the same baseline and having to move from that. I find that for me, it's been a lot more valuable and insightful to go from my own baseline and just do it that way again, because then you just start sounding like everyone else. And that's probably not a place that we want to be at.
Well, and the trust of your audience too is, if you're thinking I'm hearing from Ken and then you realize I'm hearing the one sentence that Ken wrote to try and create a paragraph, right? At some point, you just want to hear the one sentence that Ken wrote instead of a paragraph, even if that's like, maybe I've seen a meme around this where it's basically person inputs one sentence email into ChatGPT makes a great one sentence, 4 paragraphs, all the extra language. Person on the other end asks ChatGPT to take that and make it one sentence, right? And it is kind of a funny thought of how any of these things in our modern world work. People take a tool and think, well, I was only sending a sentence before, this is going to be so much better. Person on the other end says, now I have to read 4 paragraphs. Like, that sucks, right? I think in LinkedIn, maybe that's also the case. I don't exactly know how their algorithms treat longer posts or more engagement, but from a pure user of or consumer of that content, you'd rather get the key details right away. It's like when you watch a YouTube video, if it's 15 minutes on something where there's kind of a 15-second or 30-second clip that wouldn't do the same thing, you can get quite frustrated. Where it's the person doing a long intro, it's a person doing the 10 reasons why to do different things or why you don't do different things, and then they give you the 30 seconds of here's the command to run, or here's the best option. And to most consumers, probably that short clip or that short kind of highlight is all they want. Then there's probably other people that care about longer, or if they're more interested. Similar with LinkedIn, there is if you've got something truly revolutionary that you talk about, and it's going to take a full paragraph maybe, but the average post on LinkedIn is kind of, a couple sentences at most, and people kind of lean what the information is kind of most important take home, and usually that's a sentence for kind of why they care about the post or what they're going to do differently.
Yeah. I mean, realistically, that's one of the biggest problems I've had with YouTube. And one reason I've started making less YouTube videos is I feel like in order for me to get the video out there, I have to invert the story and keep people hanging on. Mm-hmm. I have to keep using retention hacks. I have to keep holding the cool detail to the very end. And for a movie, that's great because it's about entertainment, but I'm largely producing educational content. And so the idea that I have to save the most interesting and insightful stuff for the end, honestly, that doesn't really resonate that well with me overall. I think that that's largely a waste of time for the audience. But based on how the algorithms are set up, based on how the retention and things are constructed in YouTube and storytelling, it's sort of how you have to do it to be able to have success in the platform. And of course, you can, I'm not saying you can't do that effectively. I'm not saying you can't tell a story that's interesting and also have a valuable insight along the way. But I personally am in favor of just hey, here's the useful information. Yeah. And again, that's not necessarily rewarded in that specific domain. And so I think with a lot of the content, a lot of the social media, a lot of these types of things, we're kind of optimizing for the wrong thing, which is attention, not value of information, right? I think a podcast is great because hopefully most of the things we say here are different perspectives, different takes over the course of an hour. Yeah. You're getting an hour of, I maybe didn't think of it that way. This was a new perspective. This is something that was different. And it's also not necessarily as intrusive because very few people are sitting there just looking at the computer screen listening to a podcast. Yeah. And so I personally just find it very interesting to look at how the systems are designed and what they reward versus what my goals and my initiatives are overall. And again, that's one reason I'm heavily going in and focusing on podcasting more is because, I feel like I can provide value for an hour and a half, even 3 hours on my other podcast. And it's not necessarily rewarding me for like hiding all the information or anything.
Yeah. Yeah, I think that podcasting is a very interesting medium in terms of like it gives you an insight into someone's mind or like what a conversation with that person might be. And I think we're probably a lot more like off the cuff and just ready to talk on a podcast. Whereas if you're going to produce a YouTube video, how many different iterations that takes? Are you like writing somewhat of a script? Is it like a full on written script? Like there's so many aspects there of like you're getting like a very distilled, filtered like Kenji's opinion on something versus like just an off the cuff, like not a ton of editing, not a ton of like, extra, okay, let's take another cut on this. Like I didn't like how I spoke, slightly differently in that time. The sound of my voice is starting to bother me on camera, whatever the thing is. And I think like as you look at podcasting, that's why people like it, is it's a little bit more of that kind of what is it like to hang out with Ken? Yeah. And I could say I think hang out with Ken, he's pretty similar to the podcast. So that is
well, I mean, there's another side of that too, which is, and spoiler alert, I actually think about this, is what is more sustainable in the world of a really AI driven future? I think a YouTube video where you're presenting information in a generally a specific style. So if anyone who's never read Joseph Campbell, who's never read books on storytelling, there's a correct way to tell a story that works consistently over time. And essentially every YouTuber that's successful uses that formula, right? But a podcast, it's going to be a lot harder for AI to replicate genuine human conversation and the idiosyncrasies and the light bulb moments and the back and forth that podcasts have. And so I think that, at least for me, I'm really indexing more towards podcasting because I enjoy it, one. I also just think it's better hedged against AI, and it's overall a more effective medium of education than YouTube videos for me. I think that you could argue, especially with like visuals and some of the ways that you can present a story, there's benefits to that style of education. Or if you're showing a screen, whatever it might be, in a coding tutorial, definitely going to be better.
Yeah.
But I think podcasts are really looking to expand how you think and to really wrap your head around how multiple people understand a topic. It's pretty hard to beat this specific medium. So, there's a little inside baseball on I guess some of the reasons why I'm really pushing down this rabbit hole rather than continuing to focus super hard on YouTube.
Yeah, I think podcasting is interesting in my view too, because it's a little bit like a modern like book almost, in terms of the average person may have some thoughts on something and want to go to someone that is experienced in that and read a book. I think people obviously still are making books. I think readership, if I would assume, and I don't have the data on this, I would assume number of people reading books is slowly decreasing over time. Whereas I'm trying to hold it up. Other than Ken, yeah. But podcast is a way where you can basically have an expert in a field or someone that has a wildly different experience than you have, give a little bit more of like a long form context of what they think and why they think. And then you can also hear what that person thinks are interesting problems, which in and of itself is kind of an interesting. Again, in a YouTube video, you could get maybe the person's distilled thoughts, but you probably won't get the context around it, and you probably won't hear the other kind of tidbits of like, what is this person interested in, why? Because that in and of itself could be quite interesting to kind of understand.
Well, to me, that's one of the huge problems with short form content, is that we're making everything more and more bite-sized. And in every conversation you have, there's nuance that needs to be described, or else you don't fully understand the topic, or you might overlook something that's really important. We're talking about data science using a specific type of model. Well, maybe using this model is great for most situations, but there's some peculiarity in the data where it would be disastrous for us to use it in this scenario. And, TikTok culture says to use this specific, this approach is great for everything, when in reality, that's not necessarily the case. And I think that the shorter you make things, even though it's more comprehensible, you should make things shorter for yourself, not for other people, right? So if you truly understand something, you can distill information to yourself because you understand the nuance of it, and it helps you remember it now. But when you distill it in too short terms for other people, they just take that at face value and they completely miss out on all the nuance. And I think that there's an information gap that we're creating with a lot of the direction we're taking things, wanting things immediately, wanting things bite-sized, wanting things just rapidly to be consumed and to be clippable. And that's still a little bit concerning for me. I sound so curmudgeon about the content space.
I think getting older though is having some of those like opinions where you look maybe when you're first starting out in any space and you're like, whoa, it's like some of these people kind of are so dug in on, whatever the opinion that they have in some way, shape, or form. And then maybe as you get older or get more experience in any of these fields, you can understand a little bit of like, sometimes people have seen things and seen them go wrong in ways that if you're a newcomer to the field, the first time that you're seeing things break, you think, oh, that's weird. And then you've seen the same thing break 4 or 5 times and you say, I will never do things XYZ way. So I think it's a probably common thing in a variety of like the ways we as humans make our opinions are you see enough examples of something going wrong and then you can then say like, don't want to do that. But yeah, there's, that process of failing or seeing other people fail is better than failing yourself, that you then can understand like why people have opinions that they kind of deeply hold there, even if they sound curmudgeon-y.
Well, that's something over the last year that has really changed how I view a lot of things. So I used to say, oh, I just want to learn from everyone's successes, right? But you can have essentially survivorship bias in success quite frequently.
Definitely.
But on the flip side of that, I think that there's probably less bias in studying people's failures because you can deconstruct those. There's usually very clear things in failure that have contributed to that. There's obviously luck involved, but who was it? I think it was Charlie Munger. He really focuses on learning lessons of what not to do. And if he just avoids all those things in his investments, he has found pretty good success. Really.
Yeah, better to not lose your money than to 10x it, 10% chance or something. Yeah.
And so I've been thinking about that in terms of learning data, in terms of learning a lot of these things as from a new data scientist, data analyst perspective, what should I not do? How many people are telling stories of their mistakes? Again, you find those on podcasts. I don't think you really find. You occasionally find those on YouTube videos. I think I made a video about my biggest project that failed.
But definitely more rare.
But yeah, they're definitely rare. And the funny thing is people like to hear crash and burn failure stories.
Makes for a great interview question. Yeah. Tell me about a time you failed. That's a classic.
Exactly.
You can learn quite a bit about, someone and how they approach problems or how they approach solving once they've failed. I've recently been doing quite a bit of interviewing for kind of behavioral cultural fit for the company I work at, Cloudflare. And it's very interesting to hear people's response to kind of a question like that of oftentimes we're so used to talking about success, talking about here's all the great things I've done. That's your resume is just a list of like, skills and accomplishments, right? And trying to hear, there is a good way to fail at something. There's a good way to like realize, hey, I'm in over my head in this one thing and I need help. And I think that is a skill in and of itself of being able to say you failed, or again, ideally see other people that failed and learn from those. And then in those cases, figure out how do you recover from failure, because 99% of the time failure is not fatal, but it's how do you backtrack out, and hopefully the systems you built around things are robust enough where, dropping a table in a database is not the only copy that you have, or not the only, ability that you have to have all that information. I've dropped a table in internal production application when I was at AT&T. That was not a fun thing, but there was thankfully kind of an audit log of changes that were made, and I could rebuild that table. But yeah, any of those situations are things where you do it once, naively querying something that again didn't have the right protections, kind of trying to do things a little bit fast, cut a corner somewhere, just get something done at the end of the week. And then you end up with a situation that you're in over your head. And I think, yeah, hearing those types of, I think quite a few people have those stories, but it's definitely more rare on a short form video content of here's the 10 mistakes that most people probably have made in their career in software, or more specifically in data.
Yeah. Well, I would argue that everyone has had failures in their career, had failures in their personal life, had failures in these types of things. I would argue not everyone has had the same level of success.
Yeah.
And so if there's inevitability in failure, probably helps to understand how to navigate it, how to deal with it, see how other people have done with it, see case studies if you can. And again, hopefully understanding how to overcome that type of adversity is a huge asset that we can have just in general. I mean, I wouldn't say it's necessarily a failure coming up, but I want to change gears a little bit into the, maybe the security aspects of how security, like historic security systems might be failing now with the advancements in AI. And, what are the implications of those specifically relating to security?
Yes, I think there's kind of two core concepts there that are worth touching. The first one is in the context of security, what are these new models giving threat researchers or hackers that they didn't have in their toolbox before? And then the other piece is, as more and more people are deploying these LLMs or large models, what are the risks associated with deploying those? So we can kind of take those two in kind of two separate ways. I think so. The first one, in terms of the kind of how some of these models are applied from a kind of hacker or internal threat research type view, I think depending again on how sophisticated the model that people are using, you can, in a lot of ways, have the model try to find a variety of vulnerabilities. So if you have code in some, GitHub repo, which a lot of open source things are on GitHub, out there for the public to see, you can have these agents basically out there scanning any public repo, find a vulnerability. There's a list of however many vulnerabilities out there that are public in like the CVE vulnerability database. And so you could basically connect that to an LLM and then have it search public code, find a repo, find something, exploit it. There's a lot of people that also just more simply haven't patched obvious issues. So if you, again, find a major issue that was published and talked about, then you could basically have this LLM out there looking for major vulnerabilities. For example, like Apple will patch these and then put out like a little release note saying like patched a major vulnerability. They usually don't say that, but oftentimes it is, something in Safari or something in any of these other like WebKit that can be exploited. And there's articles out there talking about it. So if you think of those attackers, they could have a system that's out there scanning for new stuff or existing kind of bugs that are in these kind of open source software that maybe isn't patched. But the easier thing can be find basically something that was patched somewhat recently. So you figure a variety of people don't keep their software up to date. How often are you downloading the new Apple like iOS as soon as it's released? Probably not very often. And the same goes then for these corporate systems, where if you're trying to hack into any sort of company, how often they update their systems and keep, at the latest patches is probably not very often. Like they're, maybe doing it monthly, maybe they're doing it weekly, maybe they have a team of security engineers that are doing it daily. But the bigger the company, the more space that there is for just one thing to slip up. So kind of in that domain, I think there's a lot of people that are basically using those types of models to distill information or to go out and kind of scan for things. then beyond that, I think if you think more of kind of the autonomous agents, you could have a model that's kind of fine-tuned or trained in some way on a bunch of bugs, and then you could have it try to figure out if there's a similar bug. In the case of like SQL injection or something, basically you can have a vulnerability in a website where you have a text box that goes and queries a SQL database and is not filtered properly and allows a query to come in. That's somewhat easier to think about, but there's a variety of other like complex potential bugs out there. And if you train a model on kind of, here are all the bugs that we found, here's the database, all the information about it, try and then go look at Python, try and look at Windows, try and look at Mac OS, iOS, any of those, and try all these combinations of different things, try wild things, keep on going forever. Eventually, it probably will find something in the same way that humans that are threat researchers were doing before, of kind of understand the deep nuances of some specific package or protocol and try and break it in some way. I think as those models get more sophisticated, those kind of autonomous agents will get more sophisticated. I'm sure the US, in some way, shape, or form, like our cyber is doing probably just that, right? And I'm sure if you look at like Russia, China, any of these other big players in the global, they're definitely taking this like general approach, and it's just how successful will they be yet to be determined. But I think that concept of using those LLMs to kind of go out and do their own research is definitely a dangerous thing, because they have kind of infinite amount of time. It just depends on how many GPUs you have.
Yeah.
Yeah.
So it seems like there are already, there's plenty of unfound vulnerabilities out there, and a lot of these specific models can be trained to help find them more effectively, more rapidly, at scale, and also create new vulnerabilities based on pattern matching or doing something similar. And seems largely what they kind of be good at is writing something that's similar, or following not necessarily a line of logic, but following a line of, I guess it would be kind of autocomplete in terms of like getting into some systems or corrupting systems in two different ways, which is pretty interesting. How would you go about circumventing those things, or what are people doing to maybe prevent like an attack like that or a bot like that from?
Yeah, so I think if you think more generally, and some of these are obvious, right? It's just basically when there's a update for a system, you should basically try and patch it quickly. And this can be hard to do with a corporate system. I know, again, many companies I've worked at before have some sort of known vulnerabilities in, let's say, Docker containers that are hosting your models or other things. And maybe each model themselves or each vulnerability in there are not like a fatal or terrible vulnerability. They're kind of like something mid-level, where if someone has access to something else, they can then increase their access over here, or they can, maybe get a foothold here and pass some traffic to somewhere else. There's, a variety of different concepts there, but I think if you are kind of looking at how to defend yourself, the easiest thing is just have some sort of automated scanner that looks at your containers, and this is just for Docker at that point, but basically looks at any of your systems and keeps them up to date. Then on the other end, you can have situations where then people in an open source package or something inject something malicious that then gets retracted later. I think famously it was like the University of Minnesota had a researcher that did that into the Linux open source project. And now no one from the University of Minnesota is allowed to like contribute to Linux. So it's like, everyone. Yeah. That was like they didn't do it maliciously, but they were just, as part of their project, seeing if they could put in, a bug basically into one of the releases. And then they published a paper about it. And obviously, cool, you put a bug, but now that bug, anyone that, updated their system, in theory, you cause them to have that harm there of anything. So it can be a tricky dance there a little bit of trying to update packages and versions of things quickly, but also having to trust that, basically that open source model of people actually reviewing what was submitted and understanding the maybe more complex nuance of those kind of submitted code. And in any of these things, something will look probably fine, and then we'll have kind of a second order bug in there. And again, maybe this is a LLM trained on all these vulnerabilities used defensively, and every time there's a git commit to wherever the repo is, the bot runs and says, change this looks like a future vulnerability, or this looks like an unsafe coding practice. I think that probably is at some point what like GitHub will offer, or Bitbucket or any of these other competitors will be kind of something that does something similar to that. But we're definitely not there yet in terms of those tools being like fine-tuned enough for a company would use it. I think it also would be like expensive to run, obviously, because those LLM models, having to ingest all that data and kind of do those calculations takes a lot of GPU time, which costs a lot of money. So a little bit of trade-off.
So something that I find interesting, and you're probably more familiar with this than I am, is that essentially the good guys and the bad guys are using the same tool in that circumstance, right?
Yeah.
And so you sort of run into the situation where if one of them innovates, the other side innovates as well, unless the code is unbelievably proprietary, secure, or whatever it might be. But usually people can figure out the infrastructure once it's out there.
Yeah.
How do you solve a problem that is essentially circular like that, where it's like good guy advancement that causes a bad guy to make an advancement?
Yeah.
And just sort of keep running around in a circle.
Yeah, I think that whole concept of like a little bit of the cat and mouse game with security is what makes it interesting, right? The problem will never be solved fully because there's always people with a financial interest to try and break the systems, and then people with a financial interest to try and protect those systems. The scary thing, in a lot of ways, is the bad guys in this situation just have to win one time. The good guys have to win every time. Yeah. It's like being a goalie in soccer or hockey or something. You may have 30 shots and 2 goals, and that feels like a great percentage. But if the other team scores 2 goals, that's still a big problem for you as the goalie, right? So, and you don't even have the benefit of offense. You have to keep it to 0 all the time in order to win, which is, it's almost impossible to kind of do all that. But I think the teams that do the best are kind of out there looking at some of these great advancements that are out there. They're building layered security as well. So in security, there's a concept of zero trust, which the company I work for, Cloudflare, has products that are sold kind of in that umbrella of each system not necessarily trusting the other systems implicitly, having kind of guarding barriers or checks on any of these systems, their communication between each other. A traditional security model may look like a castle where you have a big wall on the outside, and then once you're inside, you can do whatever you want. The better probably modern approach is you isolate these components where if there is a bug in one system, the only thing they can do is take over that one component. Yeah. And so I think that core concept is a little bit of how the defending side stays kind of ahead of these.
Don't tell them the secret.
Yeah. And I think that's a definitely like well-known paradigm shift of that. And the other thing is becoming quite popular, I think, is the concept of hard tokens, which is like the thing that you basically plug into your computer. It'll be like a little USB stick, or I think for government computers, they have like a little key card type system. You plug it in, and that, if it's in your computer, holds some sort of security keys that allow you to do actions. And if it's not in your computer, then you can't do those actions. And I think those are very hard to like mimic basically, whereas the software ones are a little, have some potential. The ones in your phone is that
We set it on your desktop and
or if you are on the phone with someone. I think if you think of basically the easiest ways to break into any corporate system, it's phishing. It's getting someone to tell you information that they shouldn't be, and usually it's getting someone to give you their credentials. And so as we talk about these ML and LLM systems, that's a very fringe amount of people that are working and doing those, probably nation state actors. If you think of what the easiest way to break into someone's system is find an employee to give you access by telling them some sob story, or telling them you're an IT worker for their same company and they just don't check it, right? So I think it is important to kind of frame the discussion there a little bit of
the easiest, usually humans.
Almost always, but then the scarier failures are these system failures, because if someone gets into a system, spreads out, it's a lot harder than just resetting one person's credentials when you figured it out. These phishing attacks can also branch out into systems, but if you have more of the zero trust concepts and terminologies, also something very popular is the least privilege, which basically you're thinking of what's the least amount of system privileges that we can give a person and they can complete their job. So you don't give everyone admin to all the machines, because then you lose one person's credentials and the whole system's taken over. So it may seem obvious, but I think a lot of mid-sized and small businesses run into that situation with some of these very basic security issues before they'll ever run into someone that's advanced enough that has these exploits for trying to get in. Most of the time, the average security issue is a very human issue, a very system not set up properly, things not updated in 2 years. That I think tends to be most of, if you look by volume. And then if you look at biggest impact, for US government or for any of these things where basically they cannot have any issue and they're well-funded people trying to break in all the time, those are probably more those zero-day exploits with kind of maybe LLMs or just thousands of workers trying a variety of different things, just trying to get in.
Amazing. Hunter, those are all the questions I had. Obviously, we're going to be doing a panel together at NVIDIA GTC this year. I know we were talking about some of the comments by the CEO over there, but I still believe, obviously, enough in the product and the direction that we're going to be talking there, I believe also with Andrada. So for everyone listening, be sure to check that out, especially if you're going to check out the online details. Any final words, any final thoughts you had?
No, I think, it was always fun. I enjoy talking with you, and the podcast is definitely fun. We'll try and get you a little more experience here in the Austin food scene after this. So
sounds great.
Hyped.
I'm looking forward to it. Great, Hunter. Thank you so much. Talk to you again soon.